Hello, and thank you for joining us for our technical workshop. My name is RJ Sunderman, and with me is Eric Ironside. We're both product engineers on the GeoEvent Server development team. We've prepared today's workshop with a bit of what's new in the 10.9 release, with some best practice added for flavor. We have a lot to cover before turning control over to Greg Tiemann for the Q&A, so let's get started. I'll begin with a quick look at GeoEvent Server's positioning relative to a new offering, ArcGIS Velocity. I'll then describe a couple of use cases to provide some operational context for GeoEvent Server, but I will not be presenting its key capabilities in any real detail. An introduction with a key capabilities overview is included in a workshop Greg Christakos and I presented yesterday, ArcGIS GeoEvent Server Leveraging Real-Time GIS. I'll then quickly introduce a few of the enhancements and new functionality available in the 10.9 release. The GeoEvent services you design and publish are what really increase your return on your investment in GeoEvent Server, and I want to clear the way for Eric to show you these in a demonstration. Along the way, as we demo some of the new functionality and capabilities, we will touch a bit on best practices these enhancements were intended to address. We'll conclude our session with some questions and answers. Esri has two solutions for real-time event ingest and processing: ArcGIS GeoEvent Server and ArcGIS Velocity. ArcGIS Velocity combines the real-time event analysis capabilities of GeoEvent Server with the big data and batch analytic capabilities of ArcGIS GeoAnalytics Server. Velocity is a software-as-a-service solution for ArcGIS Online. It is Esri's first cloud-native Kubernetes product and extension to ArcGIS Online. We have two technical workshops presenting ArcGIS Velocity at the Developer Summit this year, so please look for those in your agenda. In this workshop, we will focus on GeoEvent Server, a licensing role for ArcGIS Server and part of the ArcGIS enterprise. GeoEvent Server enables real-time ingestion, analysis, visualization, and notification capabilities for your enterprise. It is your on-premise solution for ingesting data from a distributed sensor network. It processes the data records received from individual sensors. You might consider GeoEvent Server an analog of an extract, transform, and load engine that works with live data feeds to adapt and process their data in real time. Let's consider a couple of examples leveraging GeoEvent Server in an operational context. Traditionally, on New Year's Day, the city of Pasadena, California holds its biggest event of the year, the Rose Parade. A city of 140,000 swells overnight with nearly 1 million people lining the parade route, with millions more watching live on TV. Esri is on scene supporting the parade's operational staff and the city's emergency responders. GeoEvent Server is a significant part of the overall solution, receiving and updating data records for real-time display. Everything involved with the parade gets tracked: the float stream GPS position data, the locations of marching bands, equestrian teams, VIP cars, even the status and location of pre-staged tow trucks and emergency personnel are streaming live data. Solution architects often focus on an immediate need to update feature records in a geodatabase. Their goal is to design web maps and operational dashboards event staff will need in order to have a complete, common operational picture of the parade. Data visualization products enable an operations center to monitor and respond to incidents such as medical emergencies, potential public threats, and equipment breakdowns as they happen, getting out in front of a situation before it ruins the day. By unlocking real-time event processing capabilities, GeoEvent Server adds value to your existing ArcGIS enterprise. You are able to enhance web maps and operational dashboards with up-to-the-second information from sensors. You can push last known positions of field personnel out to mobile assets so they can more efficiently respond to dynamic situations as they evolve. Switching to a different use case, suppose you have a data feed providing real-time information on the cubic feet of flow per second for a number of streams or rivers in a national park. A sensor network uses fixed-place sensors which do not move, so data from the sensors does not include location information. But you would like to be able to view real-time data from these sensors on a web map or link their readings to gauges in an operations dashboard. You also want to monitor weather patterns miles upstream and provide potentially life-saving alerts to park rangers on potential flood conditions. The park's rangers are responsible for helping visitors safely experience everything the national park has to offer. GeoEvent Server provides you with the ability to enrich non-spatial data feeds server-side, detect incidents based on either attribute or spatial conditions, monitor the duration of those incidents, and generate critical alert messages, which can be sent out as either email or SMS text messages. GeoEvent Server is more than simply ingesting real-time data to update feature records. Its key benefit lies in its ability to enrich information products you have already developed. Because sometimes, a pleasant day hike can turn into an emergency situation in the few minutes it takes a flash flood to reach a national park.
A number of improvements were made at the 10.8 release to address ease of use for common workflows within the GeoEvent Manager web application. These user-focused improvements have been carried forward into the 10.9 release. The workshop Greg and RJ are presenting includes some demonstrations. Another area the product team is focusing on is analytic performance. Development on the underlying GeoEvent Server engine for previous releases sought to improve how many event records could be ingested and processed each second. For the 10.9 release, we have looked at enhancements to support best practices and how more complex analytics are configured and used. GeoEvent services that incorporate many field calculator processors or use filters to route copies of event records along different processing paths in parallel quickly reduce the real rate at which event data can be processed. A third area of improvement focuses on platform stability. Once the GeoEvent server's configuration has been established and the needed GeoEvent services designed and published, the solution is expected to run more or less hands-off. Efforts to improve resiliency and fault tolerance continue in the 10.9 release. We do understand that not every implementation or use case is the same. Different deployments require different resources to deal with a variety of environmental factors and system configurations. Often these factors are not readily apparent to the GIS analyst. You might not have immediate insight into the health of individual server machines, how much data they are trying to process, or the drawdown on system resources like RAM, CPU, or network. Looking forward to 10.9.1, the product team is going to expose new monitoring capabilities that will offer greater insight for system administrators as well as analysts. It is worth noting that the boxes on this slide are not square. This is because our development themes actually overlap. You may not see work completed for the 10.9 release until we're able to leverage it and better expose it in the 10.9.1 release later this year.
Thanks, Eric. Some of the improvements we would like to highlight are listed here. I'll take a moment to introduce them, then Eric will take a closer look at them in a demonstration. After the demo, we'll return to the slides for some additional context and follow-up. The first enhancement involves a redesign, or perhaps a reimagining, of a few existing filters and processors. We've looked to expand their functionality, performance, and also offer new options that promote GeoEvent service maintainability, stability, and efficiency. In one way or another, this first set of improvements touches on all four of our development themes. Filters are a rather straightforward element. Given an event record, they evaluate a condition and allow a data record to pass through if it meets the filter's criteria. Otherwise, the event record is discarded. Introducing multiple filters along different event processing routes can introduce performance issues into your GeoEvent Services design. Sometimes you need red cars to do this while handling blue cars differently. Multiple filters evaluating data in parallel, however, have always been an anti-pattern. To alleviate data duplication and improve event record handling, we implemented an alternative to parallel filtering, which I will refer to as a choice processor. The second filtering and processing enhancement involves the field mapper. This was one of the first processors developed for GeoEvent Server. It is used primarily to flatten an event record's data schema before the record is routed to an output and used to add or update feature records in a geodatabase. What we've done is enabled analysts to configure a field mapper not just to map one field to another, but to be able to evaluate an expression like what you can do with a field calculator. A single field mapper can now act like an array of field calculator processors. The third enhancement I'd like to mention is to our incident detector. This is one of our more complex, more powerful processors. It was originally designed to evaluate an event record, compare its attributes or geometry to a filtering condition, and if the condition is satisfied, create or update an incident. GeoEvent Server monitors these incidents to provide, for example, the duration of the incident. Suppose that a vehicle's average reported speed is less than an anticipated value for some period of time because of traffic or maybe a necessary diversion in a planned route. Or maybe a vehicle has left a pre-planned operational area and has been outside that area for a period of time. Monitoring the duration of a condition is what Incident Detector was designed to do. Detecting and monitoring conditions to identify patterns of interest is important. The original implementation of Incident Detector replaces event records it receives with a different type of data record, one that discards nearly all of the original event record's attributes. Event records emitted by the processor have an entirely different schema, an incident with information important to incident monitoring. The enhancement to Incident Detector allows an analyst to choose whether or not they want to incorporate data from the original event record into these incidents. We'll refer to this as the Keep Source Fields option. It allows incident records to be enriched with data from the event records from which the incident was derived. We've also made several improvements to the GeoEvent Gateway, the component providing GeoEvent Server with its message broker and configuration store. Some of these changes address exceptions occasionally encountered when GeoEvent Server is restarted. Others focus on making GeoEvent Server's integration of the Java resource bundles, which make up the overall event processing framework, more resilient and fault-tolerant. Internal software components were updated to leverage new configuration and tuning options, enabling us to squeeze additional performance out of the implementation. While these improvements won't necessarily be seen by analysts using the GeoEvent Manager, they will definitely feel their effect. You might consider this enhancement an improvement for both platform stability and analytic performance. Wrapping up this list, as part of the 10.9 release, we updated GeoEvent Server's Java runtime to Java 11. This gives us access to the Java Mission Control Suite, an amazing collection of tools for developing and monitoring Java applications. We have exposed new REST endpoints which will allow tools, such as Esri's ArcGIS Monitor, to examine and report on the overall health and stability of your GeoEvent Server deployment. We will also be implementing some on-demand metrics for the GeoEvent Manager web application. The ability to see metrics which relate directly to the type of data, velocity, and data volume being ingest, adapted, and processed will help analysts identify the costs associated with the analysis a GeoEvent service has been configured to perform. The new metrics should help analysts optimize their event processing workflow and debug observed issues.
For this section, we're going to move into some demonstrations of the filter and processor updates discussed above. For our first demo, let's take a look at some of the enhancements to the filtering capabilities and how they're used in practice. Here we see the GeoEvent Manager web application. This is the web app's home page from which you monitor your configured inputs, GeoEvent services, and outputs. I'd like to take a look at a situation the new choice processor is meant to address. So I'm going to click to open the GeoEvent service in the Service Designer. What you see here is an anti-pattern we call parallel filtering. The problem with this is that every data record ingested and adapted by the input has to be sent to every single filter on the screen. A GeoEvent service's decision logic is not optimized simply by publishing the service. So this configuration will end up routing all of the ingested event records so that each filter can independently decide which event records will be kept and which ones will be discarded. Event data associated with recreational shipping is allowed to pass through the first filter. Event data associated with commercial freight through the second, commercial fishing through the third, and so on. Presumably data for each type of ship needs to be handled a little bit differently, which is why we need to filter to determine the type of ship associated with each event record. In this case, 5 times as much data is routed through the GeoEvent server as is ingested because copies of each event record have to be made and sent to each filter. Analysts didn't have much of an option up until this point. This is how GeoEvent Server had implemented its filtering capabilities. This works for simple analysis in which most of the data is the same and can be processed along a single event processing path. But when your GeoEvent service has a bunch of processing paths such as this one, the pattern is wasteful and inefficient. To address this problem, we created the choice processor. Choice is a single element like the filter, and it uses the same sort of logical expressions. However, instead of offering only one filtered path, an analyst is able to incorporate logic from several filter choices into a single processor node. In this case, to add the last element for the tug, we could say is tug. And just like configuring a filter, we'll add in the criteria that would need to be true for events to pass through this choice option. So now that's in the list. The list is ordered, and they're evaluated in the order that they come. So if you need to move that up and have that one be the first one that's ordered, you can reorder things that way. So now that I have my choice configured down here, I can use that instead of all of these filters to do my evaluation. Now notice when I hook this up that each one of the optional choices in here has its own output. So now I can hook each one of these up to the desired processing path, and the events will flow in those directions. This eliminates duplicate data and logical evaluations, giving us a huge performance benefit in these parallel filtering situations. One final note on the choice processor. It has one added benefit which I believe is a big advantage over filters, and that is the otherwise option at the bottom here. This gives you the option of routing all events that don't pass the above choices to an additional processing path. So if I enable it here, you'll see that I end up with an otherwise output. Any vessel that doesn't match the above choices can be routed to this processing path and processed differently from the ones that you were looking for above. The next enhancement I want to demo is the field mapper. Opening the Service Designer, we commonly see this sort of workflow when reviewing analysts' configurations. The analyst needs to perform a number of calculations to clean up the incoming data a bit and compute some derivative values. For example, looking at the attribute speed over ground for a vessel, they need to remove the literal kph string from each attribute value and just keep the numeric portion. Maybe they need to trim the white space which is appearing in some of the vessel type attribute values. Or suppose a single attribute intended to provide specifications for a vehicle is reporting length, width, and draft as a single string, and we want to use a regular expression and pattern matching to extract each of these values and write them to separate fields. Depending on what else you need to do with this data, this can make for a lot of individual event processing nodes along a path. And when you have multiple such paths, the GeoEvent service starts to become unwieldy and hard to maintain. To address this issue, we enhanced the field mapper by adding expression evaluation support. All of the expressions you used to have to enter into separate field calculator processors, writing each expression to a single attribute field as an output, you can now enter into a single field mapper. So rather than simply mapping data from this field to that field, you can use an expression to remove literal kph string, while at the same time perhaps multiplying the numeric portion of the speed over ground attribute by a constant to convert it from kilometers per hour to miles per hour. Expressions can be applied to each attribute field in the mapping, so we trim white space from the vessel type, or configure the processor with a series of regular expression pattern matches to extract the length, the width, and the draft of the vessel into separate attribute fields, all within a single field mapper. The third enhancement I want to demonstrate for you is the changes made to the incident detector processor. If you haven't worked with a processor before, it works to monitor conditions in order to report duration. So unlike a filter which evaluates an expression and allows an event record to pass through without changing its data, an incident detector has always replaced the schema of the sensor data that it received with its own data schema, with values such as the opening condition, the closing condition, and the duration for which the condition was true. Incident detector was designed to detect and report exceptional conditions or behaviors. For example, if a vehicle enters a geofenced area in which it is not supposed to be operating, when did it enter the area and how long was it inside? What some analysts found is that they really wanted to keep the original event records fields. They wanted incident detector to function not only as a monitor, reporting information like the point locations a vehicle was observed inside or outside of an assigned area. They also wanted the processor to act like an enricher, adding its data to an event record as it was received. Previously, the only way to do this was to use the event joiner to try to join up the current incident with the last event that was received, but this proved to be somewhat fragile. Or they could get creative and use a processor like a field calculator to perhaps serialize the data from the original event record into a single field. The field they would cache the serialized data in ended up as the incident's name. So when the incident was emitted from an incident detector, they would then process the incident through a series of field calculator processors to extract the original event records from the serialized data string, in effect rehydrating an incident record with data they configured the incident detector to cache for them. And this works. But it brings us back to the problem we were trying to avoid with a bunch of extra processing nodes along an event processing route, making the overall GeoEvent service hard to design, harder to maintain, and limiting the overall number of event records the GeoEvent service can handle. The updated version of the incident detector has an option Keep Source Fields. Setting this new property value to yes specifies that the processor should create a new GeoEvent definition using a user-specified suffix and emit event records which include the original event record data as well as the incident record. So for example, if event records associated with the GeoEvent definition named sample were received by this incident detector configured to keep source fields, event records emitted from this processor would have an event definition with the name sample-incident. Here's an illustration of what such an incident might look like. In addition to the incident's ID, name, type, duration, event records emitted from the processor will have a series of attribute field names prefixed with source and a set of 3 underscore characters. The intent is to make the original source attribute field names easily identifiable without conflicting with the built-in attribute field names of the incident. Now, rather than using a series of field calculators to pull apart a serialized string, you can perhaps route the incident through a field mapper to select just the original attribute fields you want to keep, mapping them to unique names to avoid any attribute naming collisions. One additional thing to note is that we've provided the original event's geometry, receive time, and GeoEvent definition name. These are maybe helpful when you're doing further processing along the processing route. Attribute name collisions are one thing we had to consider with this enhancement when we were combining an incident schema with another random unknown schema. If the source event record already had a field with the name ID, name, type, or status, we obviously don't want the source data value overwritten with the incident data value or vice versa. So rule number 1 is source field names will have source and 3 underscores prepended to them. Another potential collision is with tagged fields. The incident detector processor requires that event records it receives have tags identifying which field is the track ID, the time start, and the record's geometry. So rule number 2 is incident fields will get the track ID, geometry, and time start tags. Notice as we combine these two schemas and apply the rules, the source field names are modified and the incident fields get the tags. It is expected that analysts will probably follow an incident detector configured to keep source fields with a field mapper in order to select the fields they actually care about, and the tags are properly assigned. Individually, each of these enhancements we have discussed so far are interesting, but let's take a look at what they can do for us in a real-world example. Here we are back in GeoEvent Manager. I've received permission from one of our customers to share a GeoEvent service that they designed and were laboring to maintain. So as it opens, you can see here that it is quite complex. In fact, I have to zoom out just to make sure that it fits on the whole screen. This customer is monitoring some underwater construction, and they are interested in identifying any surface vessel traffic that might interfere with their construction activity. They're using a pair of mutually exclusive filters to identify vessels which are fishing or not fishing. They are detecting incidents in which a vessel appears to be anchoring. They're detecting incidents in which any vessel is within a given distance of the construction zone, and they are also looking for vessels which abruptly change their heading or slow down. There's a lot of specific business logic and pattern detection they've configured into this GeoEvent service. Several processing steps are dedicated to rehydrating event records emitted from incident detectors, and a bunch of parallel filters are used to identify the patterns of interest. Again, this is a real-world example from one of our customers who implemented logic perfectly fine given the tools that GeoEvent Manager previously provided. But what if we were able to redesign this GeoEvent service using the enhancements available in 10.9 release? Can we create a more efficient event processing workflow which is both easier to read and maintain? Here's the result. This service might still look complex. There's no doubt that there's still a lot going on. But leveraging the enhancements we've demonstrated today, we were able to remove 34 processor components from the GeoEvent Services design. This redesigned service has 1/3 as many processors and filters as the original design. That's going to translate directly into huge performance improvements. We were able to keep all of the specific business logic and pattern detection this customer needed and create for them a real-time event processing workflow which is easier to review conceptually, easier to maintain, more performance, and closer in line with how GeoEvent Server was intended to be used, which will promote stability and resiliency in the solution.
Thanks, Eric. To wrap up our workshop today, I'd like to quickly review the key enhancements in the coming release. The choice processor is a new processing element we are promoting as an alternative when configuring filtering, especially parallel filtering. This enhancement is functionally complete for the 10.9 release. It should help simplify GeoEvent service design and significantly improve analytic performance in more complicated event processing workflows. We are planning some minor user interface tweaks for this processor later in 2021, mostly around how the element displays in the service designer when a large number of options are configured. Currently, the overall size of the processor node will grow as filtering choices are added, and we want to replace that behavior with a scrollable list. The field mapper enhancements for expression evaluation are also included in the upcoming release. Any expression, including nested expressions, you may have used a field calculator to evaluate should be fully supported in the new field mapper. We've added several new wrapper functions for this release, mostly functions supporting explicit typecasts such as toInteger and toDate, and we have a few more we are planning to incorporate for the second release coming later in 2021. Overall, we are seeing improved performance when multiple expressions are consolidated into a single processor. The performance gain may not be as significant as eliminating parallel filters, but it is measurable. We're expecting the new field mapper capabilities will significantly simplify the design of your more complex GeoEvent services. Eliminating intermediate processing steps will not only simplify your GeoEvent service, it will eliminate intermediate GeoEvent definitions, which are frequently needed when using a series of field calculator processors to compute intermediate data values before mapping them to a final data structure. The enhancement to incident detector, I should emphasize, is completely optional. The new keep source fields property defaults to false, so analysts upgrading their GeoEvent server do not have to change anything in the GeoEvent services they have currently configured. If you want to configure an incident detector to incorporate attribute fields from an event record received by the processor, all you have to do is toggle the keep source fields property value to true. Of course, if you're updating an existing GeoEvent service, you will need to take a close look at any event processing or filtering you have downstream from the incident detector to make sure changes in the event definition, data structure, and tagged fields of event records the processor will begin to emit are handled appropriately. A change to incident detector we did not mention earlier is a deprecation in incident record audit history. GeoEvent Server has a component which manages incidents for all of the different incident detector processors you have configured. The manager keeps track of the point or centroid of every event record's geometry which satisfies an incident detector's conditional logic. This is done primarily to facilitate adding vertices to a multi-point or polyline output associated with an ongoing incident. We have found, however, that most analysts keep the default geometry type of point, meaning there is no compelling need to keep track of all the other point vertices associated with an ongoing incident. So we optimize the manager to only keep a list of vertices when an incident's geometry type is multipoint or polyline. We never exposed access to the audit history through the GeoEvent Manager web application. Only administrative scripts using the REST API have access to the audit history, so it is unlikely this change will impact any current GeoEvent server deployments, but it will decrease the amount of memory used when larger volumes of incidents are created in conjunction with higher data ingest rates. A key takeaway, I think, from the enhancements we have highlighted is that we're listening to our customers, considering the configurations they create to perform the real-time analysis and pattern detection they need, and working to make it possible to optimize these configurations so they are more in line with GeoEvent Server's underlying design and implementation. By streamlining common user workflows, we're making GeoEvent Server easier to use with solutions that are easier to maintain and therefore naturally more stable and fault-tolerant. The new processor elements may require some reimagination in GeoEvent services you've designed, but the result will be more manageable, streamlined analytic workflows, which are more efficient, more performant, and promote overall solution stability. For the next few minutes, I would like to consider some improvements and changes made to GeoEvent Gateway. You'll recall that this is the component which encapsulates the Apache Kafka message handler and Zookeeper distributed configuration store used by GeoEvent Server. A lot of the work we've done won't be something you will see in the GeoEvent Manager web application. We've completed work identified to improve resiliency and reviewed, updated, and optimized the underlying technology. One very important change in the upcoming release is the removal of support for multi-machine deployments where multiple GeoEvent Server instances coordinate through a single ArcGIS Server site. This is a deployment pattern we've encouraged customers to move away from for a little over a year now. You will still be able to deploy multiple instances of GeoEvent Server which run independently from one another. These do not share a common configuration, which GeoEvent Gateway must synchronize across a cluster of GeoEvent Server instances. Beginning with the 10.9 release, every instance of GeoEvent Server you deploy must run beneath its own ArcGIS server with its own ArcGIS Server site. This extends the single machine high availability active-active and single machine high availability active-passive deployment patterns promoted by ArcGIS Server. GeoEvent Server's online help documentation has been updated with a new help topic, Deployment Considerations. In particular, you might want to review the help topic, Strategies for Scalability, Reliability, and Resiliency. We made the decision to remove support for multiple machine single-site deployments because we have found over time that GeoEvent Server deployments which coordinate through a single ArcGIS Server site do not meet reliability objectives. In rare cases of complete hardware failure, where a single server node in a multi-machine deployment went permanently offline, the deployment pattern we have deprecated did provide fault tolerance. More frequently, however, when a deployment was challenged by a disadvantaged network, or a machine was temporarily unavailable, or servers were restarted out of sync, the whole deployment could become effectively unusable. Recovery was tedious and error-prone, which led to promises that a system architecture would provide high availability failing to meet expectations. We therefore refactored the GeoEvent Gateway to provide better resiliency and overall system stability for the majority of our users by removing cluster leader election and in-sync replication between peer broker consumers. This means that multiple instances of GeoEvent Server will no longer be able to synchronize a shared configuration or support a clustered computing architecture. But in the end, we achieve a better, more resilient, and more stable product. Earlier, I mentioned that one of our development themes was improvements for system monitoring. The big news here is that GeoEvent Server's Java runtime was updated to use Java 11. We are exploring tools used to collect diagnostic and runtime information, such as Java Flight Recorder and JDK Mission Control, as well as web monitoring capabilities offered by Hot.io for Java applications. Streamlining common user workflows within the GeoEvent Manager web application and introducing new capabilities that allow analysts to design and publish event processing workflows that are in line with GeoEvent Server's core architecture are important. But we also want to provide system administrators insight into the health and status of individual server machines. What may seem like insignificant tweaks in a filter or processor's configuration or GeoEvent service design often have hugely significant consequences in system stability and resource utilization when perturbations in event velocity or data volume are realized during real-time operations. The development of RESTful interfaces that applications like ArcGIS Monitor can use to status GeoEvent Server within your enterprise GIS To assess system performance and resource utilization, represent enhancements for system observability. We're also working to implement on-demand metrics, which should help analysts identify and compare the costs associated with different event processing configurations. Look for more on this as part of our second release later this year. Taking a look at our development timeline, we have completed certification, and the first release for 2021, the ArcGIS 10.9 release, should be available for download next month. All of the processor and filtering enhancements we've discussed in today's workshop will be part of GeoEvent Server in this release. We're finalizing our list of work items for 10.8.1 Patch 2. This patch should include the GeoEvent Gateway stability improvements, which are being introduced with the 10.9 release. A second release, later in 2021, will bring in the metrics and observability enhancements we've been working on, some additional resiliency for inbound and outbound transports, and some security-related upgrades. We will likely be releasing 2 additional patches, one later this year and the other in the first part of next year. Critical bug fixes we identify and address as part of our 10.9.1 development will of course be considered for release as part of a 10.9 general quality patch. And of course there will be a general quality patch for 10.9.1 prepared at some point early in 2022. That concludes our technical workshop for today. Thank you for joining us. We hope our presentation on the new filtering and processing capabilities will be something you can take back and start planning for as we await the 10.9 release. I'm going to go ahead now and hand control back to our moderator, Greg Tiemann, so we can get started with the Q&A.
All right, thanks so much for joining us today, everyone, in the GeoEvent Server working with real-time analysis session. We've got a number of great questions here from you. So we're going to start the Q&A and go down the list based upon the number of upvotes that you guys submitted. So the first question here is, where is the data stored when publishing a stream service from the GeoEvent Server Manager? And what are the best practices for visualizing event records as soon as they are available through a stream service, but also store them for future analysis in a spatiotemporal big data store? RJ, you want to take that one?
Sure, thanks, Greg. GeoEvent does not inherently hold on to any of the data that it receives from event records that it is processing. It is your choice how you want to push that data out. You can push it out via a stream service as Esri feature JSON, and that enables clients to take that feature record data and display it through a stream layer. Or you could use the outputs that add and update feature records to store the data either in a traditional relational database, or if the data volume is coming in at such a rate that you are overwhelming what you can do with REST, because going through the RESTful interface to add and update features can be expensive, you may need to look at the spatial temporal big data store in order to begin accumulating data for later batch analysis, for example.
Great. Thanks, RJ. So next question from Andrew. Is there any intent on providing more visual and real-world documentation examples for processors? The current documentation seems a little vague. Common service workflows would be very helpful for understanding how to produce our own flows. RJ, you want to take that one as well?
Sure, that's a difficult question to answer. What we have found is that everywhere that GIS is being used, where location is inherently important, a time factor is also important. So where you find GIS being adopted, you'll also find real-time being adopted, because where something happens is just as important as when something happened. We don't have a lot of lighthouse use case studies that we can share, partly because some of our clients are not ready to sign the release documents needed for us to promote their solutions. That's something that you can probably reach out to professional services, because we have different managers that are focused in solution areas, different solution verticals, and they can talk with you more about applicability for real-time processing within a given area. But I guess what I'd like to say is that GeoEvent is being adopted in the federal government space. It's being adopted by national parks. It's being adopted by utilities, water, wastewater, electric. It really is everywhere. So that's, I guess, why the documentation might seem a little high level or vague, because it is so eminently configurable to what you need it to do.
Thanks, RJ. Eric, we have one for you. So it's common to have sensor values, payload hex encoded. How would you decode such payload in real time with GeoEvent?
Yeah, so that is something that I've seen quite often. Unfortunately, we don't have anything out of the box that can accomplish that. So typically when we see that, it's addressed using either a custom input or a custom processor. A good example of this is the AIS automated shipping data that we get for managing shipping data. That is a custom input that we have created that does that sort of parsing. So unfortunately, you would have to develop your own SDK, processor for that using the GeoEvent SDK. But the GeoEvent SDK is available with the install of GeoEvent. So.
Perfect. And kind of another follow-on for you, Eric. Can I create my own processors?
Yes. So GeoEvent is extensible using the GeoEvent Server SDK. It's based in Java. So you need Java 1.8 and Maven 3.6 to compile and or develop your own custom inputs, outputs, or processors. The SDK is available with GeoEvent. It's installed when you install GeoEvent, so it's available on the GeoEvent machine that you get it there, as well as the documentation. And then in addition to that, there is a session that's on demand right now, so you can pull it up anytime you want to during the Developer Summit, in which Brett and I go through some of the SDK, give you a good introduction to that, and teach you how to get started with that.
Perfect. Thanks, Eric. So next question, is GeoEvent purely for real-time data, or can you perform operations from stored data? For example, a tracking stream previously stored from tracker/field map. RJ, you want to tackle that one?
Sure. I would say that GeoEvent was designed around two fundamental principles. One, that data is being received frequently, and two, that it is being received periodically. In that sense, it really was designed for real time rather than batch processing. Every event record received is going to be processed atomically. It's not going to consider any other event records. You cannot easily compare data from one event record to another event record, for example. You're bringing the data through and processing each event record as it is received in real time. So something you might want to consider is maybe like an analogy or a use case. If I was receiving temperature data from a SCADA system, I don't particularly care that I may have missed an event record right now, this moment, because another record will be coming along in just a few moments. So that gets to the periodicity and the frequency of the data. We bring the data in real time and we process it. If you had accumulated some data and you needed to replay it through GeoEvent, you could use a system file, and by adjusting the buffer and the number of lines that are read in the number of milliseconds, I believe that particular input could read through a rather large file and process one line of data every 250 milliseconds, for example, or you could load the data into the simulator and replay it that way.
And I would just add to that, the GeoEvent simulator does have a capability that allows you to send the data at the rate that it was received. So it will inspect the timestamp on the data that's coming in and send that kind of in the real rate that's available. So that's one thing that I would look at. The other option is using like a feature service. You can configure the where clause to use a feature service to kind of time the events that are available to that input. So if you do some tricks on your feature service in your database to allow the data to be kind of periodically read in using a time-based query, that's another way that you can kind of sip at the events rather than having to read in all 10,000 or whatever your size is at once.
Great. Next question, what workflows are included for ArcGIS GeoEvent Server with ArcGIS mission or tracking capabilities? RJ, you want to tackle that one?
I would probably refer you over to the on-demand presentation that Josh Joyner and Suzanne Voss put together. It's titled Real Time in ArcGIS. It gives more of an overview of the different capabilities in ArcGIS that all touch on real time in some way. But in terms of GeoEvent, again, you're bringing the data in live, and then you are choosing to add and update feature records in order to persist that data so that some other client, some other component of ArcGIS can pull to retrieve that data as feature records. That's your primary interface between GeoEvent Server and the rest of ArcGIS is the geodatabase and the feature record set of a feature service.
Great, thanks, RJ. So next question for Eric, what programming language is used to develop custom processors?
So custom processors are developed in Java. So you will need experience and capabilities with Java itself. You can use pretty much any IDE that you want to use. I typically use Eclipse, but I know that IntelliJ and Visual Studio are two of the others that people use quite commonly. And then it's also based on Maven, so you'll need Maven. Typically, it's the latest version of Maven is fine. Java, it's Java 1.8 for anything between 10.6 and 10.8.1. 10.9 is upgrading to Java 11. You're not required to make that upgrade for developing custom components, but if you're developing custom components when you get to the 10.9 release in early May, then I do recommend you go to Java 11, assuming that you're not going to be backward compatible. So.
Great, thanks, Eric. Next question for RJ. Will or is GeoEvent Server part of the Kubernetes architecture?
The short answer is no. GeoEvent Server is not going to be re-architected to be cloud native or leverage any of the Kubernetes architecture. That is ArcGIS Velocity. That is the solution that is offered software as a service as an extension to ArcGIS Online. There are plans to bring ArcGIS Velocity on premise, but I can't commit to any sort of time frame to that. Development is undergoing and will lag behind the ArcGIS Enterprise release for Kubernetes, which is scheduled for, I believe, earlier this summer. You might want to check back with the product team toward the end of the year or first quarter next year about a Kubernetes on-premise solution.
Great, thanks, RJ. Next question, can we update to ArcGIS 10.9 from 10.6.1? RJ, you want to take that one?
Actually, I saw Eric raise his hand. I'm going to let you.
All right, Eric, you got this one.
Yes, definitely. 10.6 can be upgraded in place to 10.9. So there's not a problem doing that. However, I would recommend for pretty much any upgrade on GeoEvent Server, what I would recommend that you do is that you create a brand new install of the newest version. And then migrate your configuration file and your configuration from the old version to the new version. That just seems to give you a better upgrade and install experience to do it that way. The upgrade process, it can have some problems when it comes to certain configurations, especially when there's custom components involved and stuff like that. So I would recommend that the path that you take is to do kind of a side-by-side upgrade and do a fresh install and then migrate the configuration.
I would definitely second that. Follow the upgrade recommendations for your ArcGIS Enterprise to upgrade your server, your portal, your ArcGIS data store. Go ahead and do those upgrades in place, but then install GeoEvent fresh and bring in your configuration from the XML. That will provide the least friction.
Great, thank you both. So next question, we've been maintaining a RabbitMQ connector. Should we be moving this to Kafka, seeing how RabbitMQ is no longer maintained? I'll leave that up to you guys to decide who takes it.
So, I mean, that's kind of up to you. The RabbitMQ connector, like you said, is a custom connector. We do occasionally go back and modify it or upgrade it for a certain release. So it's kind of being maintained, but it's definitely not something that we've got our eyes on all the time. So The Kafka connector is now part of the out-of-the-box offering, so it is definitely maintained, and we have active eyes on that. So that might be a recommendation, although I would say that it's not absolutely required. I mean, if you're comfortable with the RabbitMQ and it seems to be working perfectly fine for you, then I would say just go ahead and stick with that.
Great. RJ, one for you. Could you please explain more about the field enricher processor?
Sure. So the field enricher processor is a processor that queries a feature service to bring a number of feature records into memory so that when an event record is received by the processor that has a given track ID, that track ID can be used to perform an attribute join and load the data from the secondary table into the event record. So a use case might be, I have a serial number or let's say a license plate on a vehicle and I have the vehicle's position, but I want to enrich that event record with the name of the driver who checked that vehicle out of the van pool this morning. I want to enrich that event record with data on, I don't know, maybe last maintenance schedule, whatever other data I have in the database that is not particularly dynamic, I can enrich into the event record. I can also use field enricher if I were receiving non-spatial data, for example, fixed place sensors that aren't broadcasting their location. I could set up a point feature service that has the location of those sensors and all of the serial numbers. Using the serial number to perform an attribute join, I can bring the spatial component into the event record so that then I can visualize that real-time data on a web map.
Perfect. Next question. Briefly, what is the difference between GeoEvent Server and ArcGIS Velocity? I know they share the same concepts. RJ, you want to tackle that one?
At a high level, they do share the same concepts. They're both real-time engines that are processing data through some sort of configurable workflow. ArcGIS Server has a number of different server roles, and GeoEvent is one of those server roles. So if you are looking for an on-premise solution leveraging ArcGIS Enterprise, then you're looking at GeoEvent. If you are looking more to extend the capabilities of ArcGIS Online and want to use a software as a service where Esri is hosting all of that real-time infrastructure for you, native in the cloud, then ArcGIS Velocity is what you're looking at more. If you come by the Ask Our Experts, we can go into a lot more detail on the differences, some of the limitations that you might experience between GeoEvent and ArcGIS Velocity. Just one, for example, GeoEvent has that Java SDK that you can use to develop custom processors, custom connectors, and extend GeoEvent's functionality. There is not yet a SDK available for ArcGIS Velocity. So what you're able to do through the hosted services is what you're able to do.
Perfect. Next question. Will there be material that explains in detail the new processors and offer comments on how to migrate old algorithms to new ones? RJ, you want to take that one?
I don't think there are any plans to offer any sort of migration path. The video that we just went through is a good stepping stone, and you can reach out to your customer service representative or your Esri technical advisor. We can put you in touch with solution engineers or platform engineers, enablement staff in professional services for a implementation assistance. But no, I don't think there's going to be a migration path or specific documentation on how to take a 10.8 solution and best leverage 10.9. Because again, it comes down to what you have configured your GeoEvent service to do. That gnarly service that we displayed there in the video that had the 42 different processors, they were doing quite a lot in that service, what with looking for ships that are anchoring and ships that are turning around and ships that are changing their rate of speed and ships that are entering an area or leaving an area. It would all depend on what you're trying to do and how you would want to use the new processors at 10.9 to try and simplify that workflow. That's not something we could write up in a document.
Thanks, Audrey. Next question.
Can,
Are there
let me add real quick.
Go
Sorry,
ahead.
Greg.
Yeah.
We are planning on having some blog posts and additions to there some of the documentation is updated. So for the new capabilities. So there is a little bit in the documentation that's going to be released, and as well as we are planning on having some blog releases on the GeoEvent community page at around the same time as the 10.9 release. You're on mute, Greg.
Thank you very much. Next question. Are there recommended best practices for deploying GeoEvent Server? Eric, do you want to take that one?
Sure. At 10.8.1, we added a whole section to the GeoEvent documentation. So if you haven't read it already, I would highly recommend that you head on over to the GeoEvent documentation and look for that deploy tab, as well as some of the other documentation in the administration tab has been updated as well. So it's a whole brand new section. There's many pages there that go into some of the additional concepts related to deploying and managing a GeoEvent system and planning out the architecture, as well as handling some of the concepts around high availability and disaster recovery. So if you haven't seen it yet, I would highly recommend that you go and read through that. So that's the best place to start. And then the next best place would be to go to the GeoEvent community and start asking questions there and or bounce your ideas off of folks there. And then the last place, shout out to Esri Professional Services. They're excellent people who can help you review and develop architectures and stuff like that. So in quite a little time, in just a little bit of time, they can probably help you out quite a bit there.
Perfect. Next question. Does GeoEvent Server require ArcGIS Enterprise? RJ, you want to take that one?
Yes, that's a very simple answer. You must install ArcGIS Server prior to installing GeoEvent Server. In terms of licensing, you can license your ArcGIS Server using the same GeoEvent Server license that you obtain to license GeoEvent. And what you're doing there is providing just the framework from server that GeoEvent needs to run. So you won't be able to do things like publish feature services because you haven't licensed your ArcGIS server as a GIS server. It has only the single role of GeoEvent. If you were to license your ArcGIS server both as a GeoEvent server and a GeoEvent server, that's supported, and then you would have those additional GIS server capabilities. So you can install all on one machine, but you must have the ArcGIS server component of the ArcGIS Enterprise at a minimum before installing GeoEvent.
Perfect. Next question. Can you ingest data from an AWS S3 bucket? Eric, do you want to take that one?
That's a question I don't know the answer to, unfortunately. I have not had to do that yet. It seems like it would be a common enough use case that somebody out there has done it. I'd have to do some research and find the answer to that one.
Okay, thank you.
A good person to follow up on that would be Ken Gorton. If you head on over to the Ask Our Experts and ask if Ken is available, we can put you in touch with him as a developer.
Yep.
Perfect. Next one. Should GeoEvent Server be federated or not? RJ?
That is not a question that I think we can do justice to here in a quick Q&A. There are a lot of considerations as to whether or not you want to federate. Often I will federate so that I take advantage of single sign-on capabilities. If I am leveraging stream services as the primary component or primary capability, I should say, in my solution, I often will choose not to federate. You do not have to federate in order to use spatial temporal big data store, though it is recommended. If you choose not to federate, you will have to register a server connection to an ArcGIS Enterprise portal whose hosting server has the spatial temporal data store registered against it. So I don't want to go into too much deeper into that. There's a lot of considerations as to whether to federate or not. You don't have to in order to use GeoEvent. I would recommend a simple setup being 2 machines. I would install my ArcGIS Enterprise with portal, its data store, and its hosting server on one machine. On the second machine, I would install ArcGIS Server and GeoEvent. And I probably would not federate until I feel a need to take advantage of, say, single sign-on.
Perfect. And one last very quick question we have time for. When will 10.9 be released? RJ, you want to take that?
I believe that it is early May. It should be the 6th through the 9th.
Perfect. All right. Well, thank you so much for everyone attending our session today. Continue the conversation in the Spatial Analysis and Data Science event channel under Ask Our Experts. And again, thank you. Enjoy the rest of your conference.